Every detail in this story comes from real scientific research and observation. There is a place in the universe where time stops moving forward. Not slows, not bends, stops, and then begins moving in a direction you have no word for. There is a boundary out there, invisible, perfectly spherical, absolute. You could fly through it at full speed and feel nothing, no wall, no resistance, no warning. But the moment you cross it, the direction called back ceases to exist. Not because something is pulling you, not because something is blocking your way, but because the geometry of space itself has changed. And going back is now as impossible as traveling to yesterday. Physicists have a name for this boundary, and tonight you are going to cross it. On the other side of that boundary, time does not move the way it moves here. Inside a black hole, what you think of as moving through space becomes moving through time. You cannot stop, you cannot turn around, you move forward, the way you always move forward through Tuesday and into Wednesday. Except forward now means inward, and inward means toward a point where the equations of physics themselves break down and produce an answer that should be impossible. Infinite density, a singularity. But here is what the textbooks often skip. Einstein's equations are not one-directional, they are symmetric. Run them forward in time, and you get a black hole, a region where nothing escapes. Run the exact same equations backward, and you get something else, something the math describes with equal precision, equal confidence, equal inevitability. A place where nothing can enter. A place where matter and light pour endlessly outward. A white hole. No one has ever seen one, no telescope has ever found one, but it lives in the mathematics with the same legitimacy as the black hole itself, predicted by the same equations, described by the same solutions, as real as anything Einstein ever wrote down. And then there is the tunnel, a structure that should not exist, a passage connecting two completely separate regions of the universe, or two completely separate universes, through a throat of bent spacetime, so narrow it would take a form of energy that runs backward to hold it open. Negative energy, energy that pushes instead of pulls. Energy that sounds like science fiction and yet has been measured in real laboratories, confirmed by real instruments, published in peer-reviewed journals. The Casimir effect. Real, quantified, confirmed. A wormhole held open by something the universe barely allows. Tonight you are going inside, all of it. You will cross the event horizon, the boundary where time changes direction, and you will not feel it when you pass through. You will move through the interior of a black hole toward the place where the equations break down, and you will be there when they reverse. You will travel through the throat of an Einstein-Rosen bridge, through the narrowest point where two universes press against each other and touch, and you will emerge through the exit of a white hole into a sky that no human instrument has ever pointed at, in a universe that may or may not be this one. The light from that sky will reach you, and for a moment, you will simply look at it. That is where this story goes, not to comfort, not to a safe and familiar place, to the actual, mathematically real edges of what the universe is made of, and what it might contain beyond the parts we can see. This is Quiet Science at Bedtime. If this is your kind of story, a subscribe means everything right now. Just relax, and feel free to let this play as you drift off to sleep. Now, let us begin. In 1916, Carl Schwarzschild solved Einstein's field equations for a single, perfectly spherical mass and found the black hole, a mathematical object so strange that Einstein himself doubted it could be real. For decades, it was treated as a curiosity of the math rather than a feature of the universe. Then observations confirmed it. Black holes exist. They are common, and there are millions of them in our galaxy alone. But the same equations that describe a black hole run in reverse, describe something that has never been confirmed, something that lives in the mathematics with equal precision, waiting, a white hole. Tonight, you begin at the boundary where the two meet, the event horizon of a black hole, where time changes direction and where the path to the other side begins. You are weightless. Not the weightlessness of an airplane dropping through turbulence, that brief sickening lurch in your stomach. This is different. This is the absence of any sensation telling you which way is down. You are in space, far from any planet, far from any star bright enough to matter. The darkness around you is not empty. It never is out here. It is filled with particles moving at fractions of the speed of light, with magnetic fields stretched across distances you cannot hold in your mind, with the faint remnant glow of the Big Bang itself, present in every direction, so old it has cooled to just a few degrees above absolute zero. You have been traveling toward this place for a long time, and now ahead of you, there is nothing. That is the first thing you notice. Not a shape, not a light, a nothing that is somehow more present than everything around it. A sphere of absolute absence, perfectly round, sitting in space as though it has always been here. Because in fact it has. For hundreds of millions of years, this object has been pulling the matter of its surrounding galaxy into itself, growing slowly, silently, at a rate so gradual it is almost peaceful. This is a stellar mass black hole, not one of the giants that anchor entire galaxies. Those can contain the mass of billions of suns. This one is smaller, perhaps 20 times the mass of our sun, compressed into a sphere roughly 60 kilometers across. 60 kilometers. You could drive that distance on a highway in less than an hour, and yet within that 60-kilometer boundary is contained a gravitational field so extreme that not even light, moving at 300,000 kilometers per second, has ever escaped it. The boundary itself has a name: the event horizon. You are approaching it now. You are not falling. You are simply moving in the only direction that exists from here. The space around a black hole is not what you would call normal space. General relativity tells us that mass curves space-time, the fabric of the universe that combines the three dimensions of space with the single dimension of time into one continuous four-dimensional structure. Near a massive object, this fabric bends. Near an extremely massive object, it bends dramatically. Near a black hole, close to the event horizon, the curvature becomes so severe that the geometry of space-time itself is fundamentally different from what you experience anywhere else in the universe. Here, the coordinates change. In the space you are familiar with, you can move in any direction, forward or backward, left or right, up or down. Time moves only forward. You cannot go backward in time. You cannot stop time. It flows in one direction, and you travel through it whether you choose to or not. Near the event horizon of a black hole, something strange begins to happen to this arrangement. The time dimension and the space dimension begin to exchange roles. This is not a metaphor or a poetic description. This is what the mathematics actually shows. As you approach and eventually cross the event horizon, the direction that was once inward toward the center of the black hole stops being a direction in space and becomes a direction in time. Moving inward is no longer a choice. It is inevitable, in the same way that moving forward through time is inevitable for you right now. You cannot choose not to move toward the singularity any more than you can choose to make tomorrow come before today. In the event horizon itself, that boundary you are approaching is the precise location where this exchange happens, the surface where space becomes time and time becomes space, the most dramatic geometric transformation in the known universe, happening silently and visibly at a boundary with no physical marker, no wall, no visible surface. You will not feel it when you cross. The tidal forces, the difference in gravitational pull between your head and your feet, are barely noticeable for a black hole of this mass. If this were a supermassive black hole with billions of solar masses, the tidal forces at the event horizon would be so gentle you might cross without sensing anything unusual at all. For this one, there is a faint stretching sensation, not painful, just a quiet reminder that the geometry you are passing through is no longer the geometry you were built for. You cross the event horizon. The universe behind you does not disappear. You can still see it. Light from distant galaxies still reaches your eyes, though it is compressed into a shrinking circle above you, the stars appearing closer together as the geometry of space bends the light paths around the black hole below you, if below means anything here, is darkness. The singularity. A singularity is what physicists write when they reach the edge of what the equations can describe. At the center of a black hole, the mathematics predict a point of infinite density, all the mass of the original star compressed without limit, until the numbers lose their meaning and the theory breaks down. This is not a failure of measurement or a gap in our instruments. This is a boundary of the theory itself, general relativity, which has passed every experimental test it has ever been given with extraordinary precision, simply stops working at the singularity. The answer it gives is not wrong exactly, it is undefined, like dividing by zero. The equation is still valid, the result just doesn't correspond to anything in observable reality as we understand it. Physicists have known about this problem for decades, and a small group of them believe they know what is actually happening at the singularity, and it is not the end of the story. You move through the interior. The space around you has a quality of compression, not physical compression. You are not being squeezed, but the geometry itself is contracting. The region of space-time inside the event horizon is growing smaller, closing in not because walls are moving, but because the structure of space is shrinking around you. This is the nature of the black hole interior. It is not a static place. It is a dynamic, evolving region of space-time that is collapsing and has been collapsing since the moment the star that created it died. The star that made this black hole lived for perhaps 10 million years. It burned through hydrogen, then helium, then carbon, neon, oxygen, and silicon in layers, each stage faster than the last, each fusion process producing less energy per reaction and requiring higher temperatures and pressures than the one before. When it reached iron, the process stopped. Iron is the end of the line for stellar fusion. Fusing iron absorbs energy instead of releasing it. The core, which had been supported against gravity by the outward pressure of fusion reactions for millions of years, lost that support in less than a second. It collapsed. The core imploded so rapidly that the outer layers of the star, still falling inward, hit the suddenly rigid neutron core and bounced, a rebound so violent it produced one of the most energetic events in the universe, a supernova. For a brief moment, the dying star outshone the entire galaxy it belonged to. The outer layers were blasted into space, where they are still expanding today, carrying with them the heavy elements forged in the star's interior: iron, nickel, gold, uranium, scattered across light years. The core remained. Too massive even to exist as a neutron star, it kept collapsing, past the neutron star threshold, past any known state of matter, past the point where physics as currently written has any further description. The event horizon formed around it. The black hole was born. And now you are inside it. Something ahead is different. You expected the singularity to feel like an ending, a termination, a point of no return in the most literal sense, the final destination, after which there is nothing. But there is a theory, not a fringe theory, not a speculative fantasy, but a serious proposal from physicists working at the intersection of general relativity and quantum mechanics, that the singularity is not an ending. It is a turning point. Loop quantum gravity is a framework that attempts to describe space-time at the smallest possible scales. In ordinary physics, space is treated as smooth and continuous. You can zoom in as far as you like, and the geometry remains well behaved. But loop quantum gravity proposes that space itself is quantized, that at a scale of roughly 10 to the power of -35 meters, the Planck scale, far smaller than any particle we can currently probe, space is not continuous but discrete, made of indivisible units, like pixels in the fabric of reality. At these scales, the singularity does not behave the way general relativity predicts. Because in loop quantum gravity, matter cannot be compressed to infinite density. There is a minimum size for any region of space. When matter is compressed beyond a certain point, quantum effects create an outward pressure that did not exist at larger scales, a pressure strong enough to halt the collapse and reverse it. The collapse becomes an expansion. The singularity, that place where the equations break down, where density becomes infinite and physics loses its meaning, is replaced in this framework by what physicists call a quantum bounce, a rebound. And the result of that rebound, on the other side of the bounce, is what the equations describe as a white hole. You feel it before you understand it. The compression that has been building, the slow, inexorable closing of the geometry around you, begins to change. Not slowly, quickly, decisively, the way a held breath releases. The inward motion, which has been the only available direction since you crossed the event horizon, begins to reverse. You are no longer moving toward the center. You are moving away from it. The space around you is not contracting anymore. It is expanding, and the expansion is accelerating. This is the quantum bounce. You have passed through the deepest point of the black hole's interior, the moment of maximum compression, and come out the other side into a region of space-time that behaves according to the same equations, the same physics, the same rules, but with one fundamental difference. The time direction has flipped. In the black hole, the inward direction was your future. You moved toward the singularity because that was the direction of increasing time, and you cannot move against the direction of increasing time any more than you can unring a bell. In the white hole, the outward direction is your future. You are being carried toward the boundary, a boundary that, from the inside, functions exactly like the event horizon you crossed, but with the time arrow reversed. From the outside, nothing can enter a white hole. The boundary repels matter and light, not through any force, but through the same geometric logic that made the black hole's interior inescapable. On this side of the bounce, the exit is the only direction that time points. You are going to emerge. The question, and it is a serious scientific question, one that physicists are actively working on, is where you are going to emerge into. The original Schwarzschild solution, the first and simplest mathematical description of a black hole, was extended in the 1960s by Martin Kruskal and György Szekeres into what is called the maximally extended Schwarzschild spacetime. This extension revealed something remarkable. The full mathematical solution does not describe one universe, it describes two separate, disconnected regions of space-time, connected only through the interior region, through what is, in this framework, both the black hole and the white hole simultaneously. The Einstein-Rosen bridge, a wormhole. In the Kruskal-Szekeres diagram, the full structure of this solution becomes visible. There is your universe, the one you came from. There is the black hole interior, where you have been traveling. There is the white hole interior, where you are now. And there is a second exterior region, a second universe, a second expanse of space-time, as real in the mathematics as the universe you left behind, but completely inaccessible from your original space-time, except through this interior passage. You are inside the passage right now. The geometry around you is the bridge. This is the crossing. The space through which you are moving is not empty. It has a structure. Physicists who work on traversable wormhole theory describe the interior of a stable wormhole as having a throat, a minimum radius point, the narrowest part of the tunnel, where the two universes are closest to each other. Above and below the throat, the geometry flares outward like the bell of a trumpet, opening up into the full space-time of each connected universe. You passed through the throat without knowing it. It was the moment of the quantum bounce, the point of maximum compression that became maximum expansion, the turning point between inflow and outflow, the throat of the bridge. And now you are in the outward flaring region, moving toward the second exterior, toward a white hole's exit, toward another sky. The passage has a quality of stillness that is difficult to describe in ordinary language, not the stillness of silence, because in space there is no sound to be absent, but a geometric stillness. The curvature of space around you is extreme but steady. You are moving through a region where the rules are consistent, bent, strange, unlike anything in ordinary space, but internally consistent. The physics here works, your instruments work, your thoughts work. You are not in a place of chaos. You are in a place of profound order, operating according to a geometry that was written into the structure of reality at the moment this black hole formed. The geometry changes. The walls of the tunnel, if walls is the right word for the boundary between this passage and the unreachable exterior, begin to flare more dramatically. The space is widening. The throat, the narrowest point, is behind you now. You are in the expanding section, the region that opens outward into the second universe. Ahead of you, the boundary approaches. Not the event horizon you crossed on the way in, something else. The exit, the white hole's outer boundary, the surface beyond which you will be in open space again, in a universe that has no idea you are coming. The mathematics does not tell you what you will find there. The Kruskal-Sekaris solution describes the geometry, but not the contents. The second exterior region has the same mathematical structure as the universe you came from, the same kind of space-time, the same capacity for stars and galaxies and light, but whether any of that is actually present is a question the equations leave open. You are about to find out. The boundary is close now. You can feel the geometry flattening, or rather, you can sense that the extreme curvature of the wormhole interior is giving way to something calmer, something more like the space you began in hours ago, approaching the black hole from the outside. The exit. The white hole's event horizon, approached from the inside, is not a wall. It does not push you back. It cannot. That is the whole point. A white hole horizon is one-directional, just like the black hole horizon you entered. You passed through that one without resistance. You will pass through this one the same way. You are almost through. The light from beyond the boundary has not yet reached you, or rather, it cannot reach you. The geometry of the white hole prevents external light from entering. You will not see what is on the other side until you are on the other side. That is the nature of this boundary. You cross it, and the universe opens. Stars? Not the stars you know, or perhaps they are the same stars. Perhaps this is the same universe, some distant region of it, an exit point hundreds of millions of light years from where you entered. The Kruskal-Sekaris solution does not rule this out. The white hole exit could be anywhere in the connected space-time. In principle, it could open into the same universe the black hole belongs to, just at a different location. Or it could open into something else entirely. You look at the stars above you, and for a long moment you simply breathe. You are somewhere. The distance you have traveled is not a distance that can be measured in kilometers or light years. You have moved through a structure in space-time itself, through a region where the ordinary rules of distance and direction do not apply in the ways you are accustomed to. You entered a black hole. You passed through the quantum bounce at its center. You traveled the length of an Einstein-Rosen bridge. You emerged through a white hole into this, into a sky that no human instrument has ever seen. The faint warmth of starlight reaches you. Even here, wherever here is, there are stars, there is light. There is the slow, patient churning of matter and energy that makes up the universe. And you are in it, wherever it is. The questions begin to settle in, as they always do after the immediate experience of crossing a threshold. The body, or rather the mind, because the body has been quietly following the mind throughout this journey, begins to slow. The urgency of crossing fades. What replaces it is something quieter, a recognition of where you are, not in terms of coordinates because you do not have them, but in terms of what has happened. You have been through the inside of a black hole. You have passed through the turning point that quantum physics suggests exists at the singularity. You have traveled a wormhole. You are standing, floating, existing on the other side. The stars above you hold still. They are not going anywhere. Neither are you for this moment. You are suspended in the quiet of a universe, this universe, whatever it is, and the only sound is the complete absence of sound, and the only sensation is the faint pull of distant gravity and the memory of where you have been. Rest here for a moment. There is no urgency on this side of the bridge. There is only the light of stars that may never have been named, and the vast, unhurried silence of a space-time that has been here, in whatever form it takes, for longer than any story can reach. Close your eyes if you like. The stars will still be there when you open them. You are somewhere real. And for now, that is the only coordinate you need. The light around you is unchanging. The geometry of this space, whatever universe it belongs to, is stable, calm, and old. You have been here long enough now that the strangeness of arrival has begun to settle into something quieter. Not calm exactly, more like the feeling of standing in a place you have never been and slowly realizing that the ground beneath you is solid, that the physics of this place is not so different from the physics you left behind. Or maybe it is. You do not know yet. That is the question you have been circling since you emerged. You are somewhere. The stars are real. The light reaching you is real. The gravitational pull of this galaxy, if it is a galaxy, is real and measurable. But whether this somewhere is the same universe you departed from, or a separate one entirely, is a question that requires more than just looking around. It requires understanding what a universe actually is. And that understanding begins with a tunnel. The wormhole you traveled through was not a simple tube bored through space, the way a needle passes through fabric. It was a structure embedded in space-time itself, a region where the geometry of the universe folded in a way that brought two distant points, or two separate regions, into contact through a shared interior. The mathematics that describes this structure has been part of physics since 1935, when Albert Einstein and Einstein-Rosen published a paper examining what the equations of general relativity produced when applied to a charged or neutral mass. What they found was a bridge. The Einstein-Rosen bridge, as it came to be called, appeared naturally in the mathematics, not as something added by hand, not as a theoretical convenience, but as a genuine solution to the field equations. Two separate regions of space-time connected through a shared geometry. The paper was not intended as a proposal for space travel. Einstein and Rosen were actually trying to build a model of elementary particles using these bridge structures, a project that ultimately did not succeed in the way they hoped. But the mathematical object they described has survived in the literature ever since, and physicists have been working out its properties for nearly 90 years. The first problem with the Einstein-Rosen bridge is that it is not traversable. In the original solution, the bridge exists but cannot be crossed. It forms, and then it pinches off, collapses into a singularity, so quickly that even light cannot pass through it from one side to the other. The connection exists in the equations, but it is a connection that closes faster than anything can travel. A door that opens and shuts in a time interval smaller than any practical measurement. For decades, this was considered the end of the story as far as wormholes were concerned. Then, in 1988, a physicist at Caltech named Kip Thorne, who would later share a Nobel Prize for his work on gravitational wave detection, was approached by his friend Carl Sagan. Sagan was writing a novel. The novel needed a mechanism for rapid interstellar travel that was scientifically plausible. He asked Thorne whether wormholes could work. Thorne went away and did the calculation. What he found changed the question entirely. Thorne and his colleagues, Michael Morris and Ulvi Yurtsever, published a paper in 1988 in the journal Physical Review Letters, asking a very precise question. What conditions would a wormhole need to satisfy in order to be traversable? Not just mathematically present, but actually passable. open long enough, wide enough, and stable enough for a physical object to travel through without being destroyed? The answer came with two requirements. First, the wormhole throat, the narrowest point of the passage, would need to be wide enough that tidal forces did not kill the traveler. Tidal forces are the difference in gravitational pull across the length of an extended object near a sufficiently massive or curved region of space-time. The difference in gravity between your head and your feet can be large enough to stretch and compress a human body beyond survival. For a traversable wormhole, the geometry at the throat would need to be gentle enough that this stretching stayed within survivable limits. For a wormhole throat, roughly 1 meter across, about the width of a doorway, the mass distribution would need to be carefully arranged to keep tidal forces manageable. The second requirement was more exotic. To hold the wormhole throat open, to prevent it from collapsing the way the Einstein-Rosen bridge collapses, you would need matter with a negative energy density. Ordinary matter has positive energy. Even empty space, in classical physics, has zero energy. Negative energy means something below zero, matter or a field configuration that effectively subtracts from the energy of the surrounding space. This sounds impossible. In classical physics, it is impossible. But quantum mechanics is not classical physics, and quantum mechanics explicitly allows for regions of negative energy density under specific conditions. The most well-known example is the Casimir effect. If you take two perfectly flat, uncharged metal plates and place them extremely close together in a vacuum, within a few hundred nanometers of each other, they will experience a measurable attractive force, not because of electromagnetism or gravity in the conventional sense, but because the quantum vacuum between the plates is different from the quantum vacuum outside them. Outside the plates, all wavelengths of quantum fluctuations are present. Between the plates, only fluctuations with wavelengths that fit within the gap are allowed. The others are excluded by the geometry. This means the energy density between the plates is slightly lower than the energy density outside them, lower than the vacuum, negative relative to the surrounding space. The Casimir effect has been measured experimentally. It is not theoretical. The force it produces has been confirmed in laboratory settings. The magnitude matches the quantum field theory predictions, and it represents genuine, measurable, negative energy density. The amount of negative energy produced by the Casimir effect is extraordinarily small. To hold open a wormhole large enough for a human to pass through, you would need negative energy on a scale vastly larger than any Casimir device has produced. Physicists have estimated that the negative energy required to hold open a 1-meter traversable wormhole would be comparable in magnitude to the total energy output of a large star. Whether that amount of negative energy can exist in stable form anywhere in the universe is an open question. But the physics does not prohibit it. That is what matters. The equations do not close the door. You passed through that door. You look back, not literally, because looking back toward a white hole exit from the outside reveals nothing unusual, just space. But in your mind, you retrace the path, the event horizon, the interior of the black hole, where time pointed inward, the quantum bounce where the collapse reversed, the throat of the bridge, the narrowest point, the crossing, the flaring geometry of the outward passage, the exit, the throat you passed through in the framework of loop quantum gravity and the quantum bounce was not held open artificially. It was not engineered or maintained by exotic matter placed deliberately. It was the natural geometry of the quantum bounce itself. The singularity, replaced by a minimum volume region with a geometry that connects the black hole interior on one side to the white hole interior on the other, a natural wormhole created not by any intelligence but by the physics of extreme compression meeting the quantum limit of space itself. This is the proposal at the heart of Carlo Rovelli's work on Planck stars, the idea that black holes, rather than ending in singularities, undergo a quantum bounce and become white holes, and the bridge connecting the two, the wormhole through which the bounce propagates, is not a constructed thing, it is a consequence, a geometric result of what happens when matter is compressed to the Planck density and quantum gravity takes over. This tunnel was not constructed, it was produced, the same way a shadow is produced by light, as an inevitable consequence of the geometry, the mathematics that governs the hydrogen atom and the orbit of electrons and the decay of radioactive nuclei. Quantum mechanics, applied at the most extreme scales, produces this, not as a special case, not as an exception, as a natural output of the rules. You are floating in the evidence of those rules. The stars around you are at distances you cannot currently measure. Without a reference catalog, without a map of this sky to compare against the maps you know, you cannot say how far away they are, or whether they are the same kind of stars you are accustomed to. What you can observe is their light, and their light tells you something immediately, something basic and profound. They are producing it the same way. The spectral lines in starlight are a fingerprint of atomic physics. When hydrogen burns, it emits light at very specific wavelengths, a precise set of colors determined by the energy levels of the hydrogen atom. These energy levels are set by the fundamental constants of nature, the charge of the electron, the mass of the electron, Planck's constant, the speed of light. If any of these constants were different, even slightly different, the spectral lines would shift, the fingerprint would change. You look at the light from the nearest star. The hydrogen lines are exactly where they should be. The physics here is the same. This does not definitively prove you are in the same universe you came from. The same physical constants could exist in a separate universe. Many cosmological models allow for, or even predict, multiple regions with similar or identical physical laws. But it is information, it is a data point, it narrows the possibilities. The universe you are in follows the same rules as the one you left. You begin to think about what that means. If the physical constants are the same, then atoms here form the same elements. The same elements produce the same chemistry. The same chemistry, under the right conditions, produces the same complexity, proteins, cells, nervous systems. The chain from physics to chemistry to biology is long, but it follows the same links regardless of which universe runs it, as long as the fundamental constants hold. You are looking at stars that could, in principle, have planets. Planets that could, in principle, have liquid water. And liquid water, on a planet at the right distance from a star with the right mass, in a system that has been stable long enough, liquid water, in the presence of the right chemistry, has a known tendency to produce life. Not certainly, not inevitably, but with a probability that is not zero, and that the universe, this universe, or any universe with these constants, has had billions of years to act on. You look at the stars and think about what might be looking back, or not looking back, or not yet evolved to the point of looking, or already gone, burned out in the time between now and the moment its civilization arose. The scale of stellar time is not easy to hold in a human mind. The star nearest to you, assuming it is a star of roughly solar mass, has been burning for perhaps 5 billion years, or perhaps 10, or perhaps 2. You cannot tell from here, but the range is comprehensible. The Sun has been burning for 4.6 billion years and has roughly the same amount of time remaining before it expands into a red giant and consumes the inner planets of our solar system. These are numbers that have been measured, that have been confirmed through radiometric dating of meteorites and helioseismology, the study of sound waves moving through the interior of the Sun, and through stellar evolution models that match observations of thousands of other stars at different stages of their lives. The star in front of you is going through its own version of that story. Right now, hydrogen nuclei in its core are fusing into helium at a rate of roughly 600 million tons per second, the same rate our Sun burns, scaled by whatever mass this star carries. Each fusion reaction converts a small fraction of that mass into energy according to Einstein's most famous equation, E equals mc squared. The c squared term, the speed of light multiplied by itself, is an enormous number. 300,000 kilometers per second squared is 90 billion kilometers squared per second squared. This is why a small amount of mass produces a staggering amount of energy, and why stars can burn for billions of years on what is, in relative terms, a finite fuel supply. This is happening right now, inside that star. The light reaching your eyes left its surface 8 minutes ago. If the star is roughly the same distance from you as the Sun is from Earth, or thousands of years ago, if it is farther, you are not seeing the star as it is. You are seeing it as it was at the moment that particular light began its journey. Every observation in astronomy is an observation of the past. Every star you have ever seen from Earth is a star you were seeing backward in time by the precise number of years it took for the light to cross the distance. You look at the star and you are looking into its history. Here in this universe, wherever this is, the same is true. Time flows in the same direction. Light travels at the same speed. The past is inaccessible, and the future is unwritten, and the present is this exact moment. You floating in the space between stars, in a universe that the mathematics of a black hole delivered you to. Breathe. The space around you is not silent in the scientific sense. Space is filled with radiation, the cosmic microwave background, the afterglow of whatever beginning this universe had. If this universe had a beginning like ours, the CMB here would be a faint, nearly uniform glow of microwave radiation at a temperature of approximately 2.7 Kelvin, spread across the entire sky, the same in every direction to within 1 part in 100,000. It would be invisible to your eyes, which are tuned to a narrow band of electromagnetic frequencies in the visible spectrum. But if you had a microwave detector, a radio telescope sensitive to wavelengths measured in millimeters, you would see it, a soft, ancient light filling everything, the oldest light in this universe, still traveling, still carrying the information of what the beginning looked like. You do not have that detector with you, but you know it is there. In, out. The distances between stars here, assuming this is a galaxy, assuming the stellar density is similar to what you know, are measured in light years. The nearest star to our Sun is Proxima Centauri, 4.24 light years away. A light year is the distance light travels in 1 year, moving at 300,000 kilometers per second, approximately 9.5 trillion kilometers. 4 light years is roughly 40 trillion kilometers. If you tried to drive there at highway speed, 100 kilometers per hour, it would take you approximately 43 million years. These are the actual distances between stars. Not metaphorical distances, not poetic exaggerations, real, measured, confirmed distances, calculated using parallax, the apparent shift in a star's position as the Earth moves around the Sun, and confirmed by the European Space Agency's Gaia mission, which has measured the distances to over 1 billion stars in our galaxy with unprecedented precision. The nearest star to you here in this sky is at some unknown version of that scale. Close in cosmic terms, unreachably far in human terms. You are not going there tonight. Tonight you are staying here in this patch of space between the stars and simply being present in it. This is enough. This is more than enough. You have crossed the interior of a black hole and emerged through a white hole into a universe that may or may not be your own, and the appropriate response to that is not urgency. The appropriate response is stillness. The stars are moving. All stars move, carried by the rotation of their galaxy, pulled by the gravitational influence of their neighbors. But at this distance and on this timescale, they appear perfectly fixed. Pinpoints of light against the dark, ancient nuclear fires burning at distances your body cannot feel and your mind can only partially grasp. You watch them. You do not have to understand everything right now. You do not have to figure out which universe this is, or how to get back, or what the fact of your arrival here means for the physics you thought you understood. Those are questions for another time, questions for the part of you that is awake and alert and processing. Right now, another part of you is taking over. The part that simply receives. The light reaches you from every direction, not just from the stars, though the stars are the most obvious sources. From the diffuse glow of interstellar gas, excited by ultraviolet radiation from nearby hot stars, and re-emitting it as visible light in the red wavelengths of hydrogen alpha emission, from the faint reflection of starlight off dust particles floating in the space between star systems, contributing a barely perceptible scattered glow to the background, from the infrared emission of cold dust clouds, invisible to your eyes but radiating heat into the surrounding space. Space only appears dark because most of what fills it is outside the narrow band of wavelengths your eyes evolved to detect. If you could see in radio waves, the sky would be bright with the emission of hydrogen atoms spread across the galaxy. If you could see in X-rays, you would see the violent hot plasma around neutron stars and black holes blazing across the sky. If you could see in infrared, the dust clouds between the stars would glow softly in every direction. The universe is full of light you cannot see. It always has been. You think about what you know of the universe you came from. The Milky Way, your galaxy, contains between 100 billion and 400 billion stars, depending on how faint an object you are willing to count. It is a barred spiral galaxy, roughly 100,000 light-years across, and about 1,000 light-years thick at the disk. The Sun sits about 26,000 light-years from the center, in a region called the Orion Arm, one of several spiral arms trailing outward from the central bar. If this universe you are in now has a galaxy of similar size, you are somewhere inside it. Inside a structure containing hundreds of billions of stars, each one a nuclear furnace at a different stage of its multi-billion-year life, each one potentially surrounded by planets, each planet potentially carrying the raw materials for chemistry and chemistry the raw materials for life. The number of stars in the observable universe is estimated at 2 times 10 to the power of 23. 200 sextillion. This is not a round number invented for impressiveness. It is a calculated estimate based on the number of galaxies in the observable universe, roughly 2 trillion, a number revised upward significantly in 2016 based on Deep Hubble Space Telescope observations, multiplied by the average number of stars per galaxy. 200 sextillion nuclear fires, each one burning hydrogen into helium, or helium into carbon, or moving through the later stages of stellar evolution, or already dead, collapsed into a white dwarf, or a neutron star, or a black hole, each dead star leaving behind the heavy elements it forged in its interior, each supernova scattering those elements across light years of space, seeding the next generation of star systems with the ingredients for planets, for chemistry, for everything that came after. You are made of those elements. The carbon in your body was forged in the interior of a star that died billions of years ago. The iron in your blood was created in a supernova. The calcium in your bones, the oxygen you breathe, the nitrogen in your DNA, all of it was produced in the nuclear furnaces of stars that lived and died before the sun was born. You carry the universe inside you. And right now, the universe, this universe, wherever it is returning the favor. In, out. The quality of the darkness here is changing. Not literally. The stars are not dimming, the light is not fading, but your perception of it is shifting. The alertness you carried through the crossing, through the event horizon, through the interior, through the tunnel, through the exit, is softening. The data is still arriving. The stars are still there, but the urgency of processing it, of cataloging it, of figuring it out, is quietly releasing its grip. This is what the body does with vastness. It reaches a point where the scale is simply too large to hold an active attention, and it lets go, not out of defeat, out of a kind of natural wisdom. The universe is not a problem to be solved. It is a place to be in, and being in it, truly being in it, as a small warm thing floating in an enormous cold dark, full of ancient light, requires a different quality of attention than solving a problem. It requires receptiveness. You let the light come to you. You let the distances be what they are. You let the question of which universe this is remain unanswered for now, because it will be answered, or it will not, and either way the stars will continue burning, and the space between them will continue expanding, and the physics will continue operating according to the same rules it has followed since whatever moment of origin gave birth to this particular expanse of space-time. Nothing out here is waiting for you to figure it out. It is simply here. And so are you. You drift. Not sleeping, not yet. But the edge between awareness and rest is closer now than it was. The journey has been long. The crossing was real. The physics you have moved through tonight is the physics of the actual universe, the actual equations, the actual proposals that actual physicists, with actual tenured positions at actual universities, have spent their careers developing and testing and refining. This is not invented. The black hole you entered is of a type that exists in the galaxy. Stellar mass black holes have been confirmed by gravitational wave detectors when they collide and merge, producing ripples in space-time that travel at the speed of light and are detected by instruments sensitive to a displacement of less than 1/10,000th the diameter of a proton. The quantum bounce at the singularity is a prediction of loop quantum gravity, a serious and actively developed framework for quantum gravity. The Einstein-Rosen bridge is a direct mathematical consequence of general relativity. The white hole is the time-reversed solution of the same equations that describe the black hole. All of it is real, in the sense that the mathematics is real, the physics behind it is real, and the universe is under no obligation to restrict itself only to the phenomena that human instruments have so far managed to detect. Everything the equations permit, the universe eventually produces. And the equations permit this. All of this is real. You are in a universe. You do not know its name, or its age, or its size, or whether anyone in it has ever looked up at a sky and wondered if something could travel from somewhere else to here. But you are here. And the light is here. And for now, that is the whole story. Pinpoints of light burn at incomprehensible distances. They have been at this fusing, emitting, enduring for longer than the Earth has existed, and they will continue long after everything on its surface has changed beyond recognition. They are patient in a way that nothing alive can be. And tonight, in their patience, they are keeping watch over you. Over whatever small, warm, aware thing you are, floating in the space between them, on the far side of a bridge that the universe built for itself, in a place the mathematics said was possible and the physics did not forbid. You are exactly where the equations put you. Rest now. The universe will still be here. It always is. Nothing out here is in a hurry. Neither are you. Let the light come from wherever it is coming from, and let it fall on you without asking it to explain itself, and let the distances do what distances do, which is to hold things apart with a patience and a completeness that no urgency can touch. You are in the dark between the stars, and in the light between them simultaneously, as every traveler through this universe has always been. The crossing is complete. What comes next is not another crossing. What comes next is the oldest question the universe has ever asked of anything alive enough to ask it back. Where did all of this come from? And the answer, the real answer, the one that the physics is slowly assembling, piece by piece, in laboratories and observatories and in the papers of physicists who spend their lives looking at what the equations actually say rather than what they wish they said, that answer is stranger and more beautiful than any story invented to replace it. It begins with the question of what a universe is, and whether ours is the only one. Not the only one in a poetic sense, not the only one as a metaphor for perspective, but the only one in a literal, physical, mathematical sense, the only connected region of space-time that has ever existed, the only stage on which physics has ever run, the only expanse of geometry in which stars have burned and matter has arranged itself into complexity. The answer the physics gives is probably not. And the reasons for that answer are written in the same equations that brought you here. You look up at the stars above you, wherever above is, in a space where gravity defines the local geometry and there is no universal up or down, and you begin to think about origins. Not your origin, the origin of the universe itself. This is where the story goes next. Not away from you, not into abstraction, but deeper into the question that the crossing has made unavoidable. If a black hole can give birth to a white hole, if the physics of extreme compression followed by quantum reversal can produce an expanding region of space-time on the other side of the bounce, then what does that say about the moment our universe began? The Big Bang. 13.8 billion years ago, all the matter and energy in the observable universe was compressed into a region of space, smaller than an atomic nucleus. The temperature was so high that the fundamental forces of nature, gravity, electromagnetism, the strong nuclear force, the weak nuclear force, were unified into a single interaction. Matter and antimatter existed in nearly equal quantities and annihilated each other continuously. Space itself was expanding at a rate that would seem, from the outside, almost instantaneous. The exponential inflation that stretched quantum-scale fluctuations into the large-scale structure of the universe we observe today. This is not mythology, this is measured. The cosmic microwave background, the faint afterglow of the Big Bang, still present in every direction of the sky, measured with extraordinary precision by satellites including WMAP and Planck, encodes the conditions of the universe when it was 380,000 years old. The tiny temperature variations in that glow correspond to tiny density variations in the early universe, and those density variations are the seeds of everything that followed: galaxies, clusters of galaxies, the cosmic web of filaments and voids that structures the universe on the largest scales. The measurements are precise to 5 significant figures. The model that produces them, the standard model of cosmology, fits the observations with a fidelity that rivals any other scientific theory ever constructed. But the model has an edge. It describes what happened from the first fraction of a second onward, with increasing precision as you move forward in time. But at the very beginning, at the moment of the Big Bang itself, the same problem appears that appears at the singularity of a black hole. The equations break down. Infinite density, infinite temperature, a point where the mathematics produces undefined answers, and the theory reaches its own boundary. The same boundary you passed through earlier tonight. This is not a coincidence that physicists have missed. It is a pattern they have noticed and taken seriously. The singularity at the center of a black hole and the singularity at the beginning of the Big Bang are mathematically similar objects. They are both places where general relativity reaches the edge of its validity, both places where the density of matter becomes formally infinite, both places where a more complete theory, one that incorporates quantum mechanics into the description of gravity, is needed to say what is actually happening. If loop quantum gravity is right about the black hole singularity, if the quantum bounce replaces the singularity and produces a white hole on the other side, then the same logic may apply to the Big Bang singularity. The Big Bang may not have been a beginning. It may have been a bounce, a rebound from a previous state of extreme compression, a quantum bounce operating on a cosmological scale that reversed a collapsing universe or a collapsing region of some larger space-time and sent it expanding outward into what we now call our universe. This is the proposal at the heart of loop quantum cosmology, the application of loop quantum gravity to the universe as a whole. In this framework, the Big Bang is replaced by the Big Bounce. Before the expansion we observe, there was a contraction. A previous phase of the universe, or of whatever preceded it, was collapsing, growing denser and hotter, until it reached the Planck density and quantum gravity effects became dominant. At that point, the collapse reversed. The universe began to expand. What we observe as the Big Bang, the hot, dense, rapidly expanding early universe, is the aftermath of that reversal. The echoes of what came before may be present, faintly, in the cosmic microwave background. Some physicists have searched for patterns in the CMB that would be consistent with a pre-bounce universe, circular patterns, or slight deviations from the predictions of simple inflation that could be interpreted as signals from a previous cosmic phase. The evidence so far is suggestive but not conclusive. The question is open, but the framework exists. The mathematics is developed. The proposal is serious. And if it is right, if the Big Bang was a quantum bounce, then the universe you came from did not begin. It continued from something that came before, through a moment of maximum compression and reversal, into the expanding universe that produced stars and galaxies and planets and, eventually, a being capable of crossing a black hole and emerging into another sky. You look at the stars above you. You think about what it means to be continuous with something that preceded the universe. Not metaphorically continuous, physically continuous. The matter in your body, the atoms forged in stars, scattered in supernovae, assembled over billions of years into the chemistry of life. That matter has a history that may extend backward through the Big Bounce, through whatever preceded it, through a chain of cosmic cycles that the physics does not yet fully describe, but does not prohibit. You are not just made of stars. You may be made of something older than the universe. That thought settles into you slowly. The stars above hold their light, each one a version of the same story: hydrogen, gravity, time, and the nuclear physics that converts mass into energy at a rate so gradual that a star can burn for billions of years without exhausting itself, each one on its own trajectory through the life cycle of stellar evolution, each one leaving behind, when it ends, the seeds of what comes next. Nothing in the universe ends without becoming something else. The star that formed this solar system, if this is a solar system, coalesced from a cloud of gas and dust that was itself the remnant of earlier stars. The black hole that you entered was formed from the collapse of a star that had burned for millions of years. The quantum bounce at its center produced the white hole whose exit delivered you here. Each stage is the input for the next. The universe is not a sequence of events with a beginning and an ending. It is a network of transformations, each one conserving what the physics requires to be conserved: energy, momentum, information, and converting everything else into the next form. You are one of those transformations. You arrived here from somewhere. You will leave here for somewhere else. The direction and the timing are uncertain, but the pattern is not. The pattern is as old as the physics, and the physics is as old as whatever beginning or bounce gave rise to the rules. The stars are patient. The geometry of this space-time is stable, as far as you can tell. The expansion of this universe, if it is expanding, if it has a cosmological constant or a dark energy component that drives acceleration, is happening at a rate too slow to perceive on any human timescale. The distances between galaxies are growing, as they are growing in the universe you came from, but at a pace measured in megaparsecs per second per megaparsec, which translates to a recession rate of roughly 70 kilometers per second for every 3.26 million light-years of distance. The universe is expanding, but not in a way you can feel. You are at rest relative to the local stars. The only motion you are aware of is your own breathing, the slow, quiet rhythm that your body maintains without being asked, the in and out of air, the rise and fall of your chest, the faint warmth of your own temperature against the background cold of space. Even in the deepest cold of space, and space is cold, just a few degrees above absolute zero, the cosmic microwave background its only warmth, there is something present, faint, old, but real. You breathe. The nuclear engines above you cycle through their fuel the same way, expanding and contracting across millions of years, pulsing in some cases with a regularity so precise it rivals an atomic clock, emitting and converting without pause. You are a small version of the same process. Carbon-based chemistry running on the energy of a star, producing complexity, producing awareness, producing the capacity to cross a black hole and emerge on the other side and look up at an unfamiliar sky and think this is real. This is all real. Everything you are experiencing right now is real. The mathematics that describes it is over 100 years old and has passed every experimental test it has ever faced. The quantum mechanics underlying the bounce and the bridge has been confirmed to a precision of 1 part in 10 billion in laboratory experiments. The cosmological models that predict the structure of the universe from its first moments have been validated by satellite observations with a precision that places our understanding of the universe's composition, ordinary matter, dark energy, within a fraction of a percent. The universe is not a mystery that refuses to be understood. It is a mystery that is slowly, patiently allowing itself to be understood. On human timescales, the pace of that understanding feels rapid. A century of physics has produced a picture of the universe that would be unrecognizable to anyone alive before Einstein. On cosmic timescales, it is barely a moment. The universe has been here for 13.8 billion years. Human science has been asking serious questions about the structure of space-time for roughly a century. We are at the very beginning of knowing. And what we know already is this extraordinary. You look at the stars. You do not try to name them or catalog them or figure out what kind of stars they are, whether they are main sequence or giant or dwarf. You just let them be what they are, points of nuclear fire at enormous distances, ancient and patient and indifferent to whether anyone is watching. They were here before you. They will be here after. And for this moment, this quiet, specific, unrepeatable moment, you are here with them. In whatever universe this is, beneath whatever stars these are, on the far side of a bridge that the physics built from its own internal logic, in a place the equations predicted and the mathematics described, and the universe, in its 4 billion year habit of doing what the physics allows, apparently produced. You are here. The stars are here. And somewhere, in the direction you cannot quite identify, across a distance you cannot measure, there is a white hole emitting matter and light into this universe, gently, at a rate too slow to notice from where you are, adding to the total inventory of this space-time in the only way a white hole can. By letting things out. By being, in its quiet way, the end of one story and the beginning of another. Let yourself rest in that. The story continues, but not tonight. Tonight, the stars are enough. Tonight, the distance is enough. Tonight, the fact of being here, in a universe that the physics said was possible, in a place that the mathematics put you, is more than enough. It is everything. The light is soft around you. The stars do not flicker here the way they appear to flicker from the surface of a planet. That shimmering is caused by atmospheric turbulence, by pockets of air at slightly different temperatures, bending starlight as it passes through. In space without atmosphere, stars are steady, fixed points, unblinking. They hold their light without trembling. And in their steadiness, in the absolute stillness of their light, across the vast distance between you and them, there is something that the body recognizes, even when the mind is too occupied to name it. Safety. Not the safety of walls or shelter or warmth, though those are real and important and worth having, but the deeper safety of a universe that operates according to rules, that does not change the rules without warning, that is, in its fundamental structure, consistent and reliable, and governed by mathematics, that does not play favorites. The same physics that held you together through the crossing is holding you together now. It will continue to do so. You are made of matter that the universe has spent billions of years assembling. It is not going to let you fall apart easily. Rest. The crossing is behind you. The stars are ahead of you. And the universe, this one yours, whatever the relationship between them turns out to be, is doing what it always does. Continuing. And so are you. The stars you have been watching have not moved. The light reaching you is the same light it was minutes ago, the same ancient nuclear output, crossing the same distances, arriving at the same eyes. You have been here long enough now that the crossing itself is beginning to feel like something that happened to a slightly different version of you, one that was moving, urgent, crossing boundaries. This version is still. The space between the stars expands, slowly, at the rate the cosmological constant dictates. You are here inside all of it, assembled from the same material that the stars themselves are made of. This is the fact that keeps returning, the one that the crossing has made impossible to treat as abstract. You are not observing the universe from outside it. You never were. There is no outside. The universe is not a container you are placed in. It is a structure you are part of, made of the same matter, governed by the same physics, continuous with everything around you in a way that is literal and physical and measurable. The carbon in your body was forged in a star through the same triple alpha fusion reaction that powers the stars above you now. The oxygen, the nitrogen, the iron in your blood, each element produced in a stellar interior at a specific temperature during a specific stage of a star's life, and scattered into space by the explosion that ended it. You are an assembly of stellar outputs, an arrangement of matter that passed through the interior of at least one star, probably several, before being gathered into the cloud that formed the sun and eventually you. You are older than the Earth. The atoms in your body predate the solar system. They were drifting through interstellar space, some of them for hundreds of millions of years, before gravity gathered them into the collapsing nebula that became the sun. The sun formed 4.6 billion years ago from a cloud of gas enriched by previous generations of stars. The Earth formed from the leftover material in the disk around the young sun, accreting over millions of years into the rocky planet it now is. And the atoms that make up your body were already ancient by the time they were incorporated into the chemistry of life. The universe recycled them. It takes the outputs of dead stars, the heavy elements scattered by supernovae, and uses them as inputs for the next generation of stellar systems. new stars, new planets, new chemistry, the same atoms cycling through different configurations across billions of years, passing through stellar cores and supernova shockwaves and interstellar clouds and planetary surfaces and oceans and cells, and eventually into a being capable of crossing a black hole and thinking about where its atoms came from. This is not a poetic interpretation of the science. This is what the science says. Stellar nucleosynthesis, the production of elements inside stars, was worked out in detail in a landmark 1957 paper by William Fowler, Geoffrey Burbidge, Margaret Burbidge, and Fred Hoyle, known as the B²FH paper. It remains one of the most comprehensive and influential papers in astrophysics. Fowler received the Nobel Prize in Physics in 1983 for this work. The paper mapped out, element by element, the nuclear reactions in stellar interiors, responsible for producing each one, matching the predicted abundances against the observed abundances in the Sun and other stars with remarkable agreement. The science of where your atoms came from has been settled at this level for nearly 70 years. You are the universe thinking about itself. That phrase is used often enough that it risks losing its precision, so here is the precise version. The matter that constitutes your nervous system, the neurons firing in patterns that produce thought and perception, and the experience of understanding, that matter was produced in the same nuclear processes that produced the matter in the stars above you. The physical substrate of your consciousness is continuous in terms of its atomic composition with the physical substrate of the universe around you. There is no sharp boundary between you and the rest of the cosmos at the level of the atoms. The boundary is organizational. You are a particular arrangement of atoms that has the property of being aware of other arrangements of atoms. And right now, that arrangement, you, is floating in a universe on the far side of a wormhole, made of the same material as everything around it, looking at stars that are made of the same material as the atoms inside it, in a moment of recognition that the physics has been quietly building toward since the first particle came to rest in its ground state after the Big Bang, or the Big Bounce, or whatever gave this expanding region of space-time its initial conditions. You are here. That is not a small thing. The number of steps between the moment of the universe's beginning and this moment, your moment, here now, is incomprehensibly large. The number of conditions that had to hold, the number of physical constants that had to take the values they take, the number of nuclear reactions that had to proceed in the right direction, the number of stellar generations that had to live and die and scatter their material at the right time, in the right place. The chain of causality from the first moment to this one is so long and so specific that the fact of your existence is, from a certain angle, the most improbable thing in the universe. From another angle, it is the most inevitable. Because the universe is not a random generator, it operates according to rules. The rules produce consequences. The consequences accumulate over billions of years. And in a universe large enough, old enough, and rich enough in matter and energy, the consequences of the rules include complex chemistry, and complex chemistry includes life, and life includes the kind of life that can ask questions about how it got here. The universe did not intend you, but it produced you following its own rules, without exception. That is something. The light from the stars above is shifting, almost imperceptibly, as this region of space continues its slow expansion, the wavelengths of light stretching very slightly as the space through which they travel grows. This is the cosmological redshift, the same phenomenon that Edwin Hubble observed in 1929 when he measured the spectra of distant galaxies and found that the light from every galaxy outside the local group was shifted toward the red end of the spectrum. Shifted because the galaxies were moving away because the space between them was expanding. Hubble's observation was the first direct evidence that the universe is not static, that it is growing, that if you run time backward, the universe gets smaller, denser, hotter, more compressed, until you reach the moment of the Big Bang or the Big Bounce, where the compression was at its maximum and the expansion began. The expansion has been happening ever since, and it is accelerating. In 1998, two independent teams of astronomers, one led by Saul Perlmutter, one led by Brian Schmidt and Adam Rees, published results from observations of Type 1a supernovae, a class of stellar explosion that produces a consistent peak brightness and can therefore be used as a standard candle for measuring cosmic distances. They expected to find that the expansion of the universe was slowing down, pulled back by the gravitational attraction of all the matter in it. What they found instead was the opposite. The expansion is speeding up. Something is driving the acceleration, something that fills all of space, exerts a negative pressure, and acts against the attractive pull of gravity on the largest scales. Physicists call it dark energy. The cosmological constant, the term Einstein added to his field equations, then removed, then regretted removing, turns out to be real, and its value corresponds closely to the observed rate of acceleration. Dark energy constitutes approximately 68% of the total energy content of the universe. Ordinary matter, the atoms, the stars, the gas, the planets, the black holes, constitutes approximately 5%. Dark matter, which interacts gravitationally but not electromagnetically and cannot be directly observed, constitutes approximately 27%. Everything you have ever seen with your eyes, everything that has ever been detected by any instrument, everything that constitutes the visible, tangible, measurable universe, is 5% of what is actually there. The other 95% is present. It is real. It has measurable effects on the structure and evolution of the universe, but it has not yet been directly detected, and its fundamental nature remains one of the deepest open questions in physics. You are floating in a universe that is mostly made of things you cannot see. That has always been true. It is true here, in this sky that may belong to a different universe or a distant region of your own, and it was true in the universe you came from, and it is true everywhere the physics runs, which is everywhere. In, out. The stars are quieter now. Not literally, stellar nuclear fusion is not a quiet process. The pressure waves moving through the interior of a star, driven by the energy of fusion reactions, create oscillations that traverse the entire stellar body. Helioseismology, the study of these oscillations in the Sun, has revealed the interior structure of our star in extraordinary detail, including the size and composition of the solar core, the rotation rate of different internal layers, and the depth of the convective zone where energy is transported by the motion of plasma rather than by radiation. The stars are not quiet, but you are. The alertness that carried you through the event horizon, through the interior, through the quantum bounce, through the wormhole throat, through the white hole exit, and into this open space, that alertness has done its work. It brought you here. It kept you oriented through the crossing, and now it is releasing the way any sustained effort releases when the task is complete. The task is complete. You are on the other side. And the other side is this: stars, space, expanding geometry, ancient light, and the same physics that has governed every moment of the universe since its beginning, running as reliably here as it has always run everywhere else. There is nothing more to do right now. There is only the being here. You let your attention soften, not withdrawing from the universe. You could not do that even if you wanted to. You are inside it, made of it, continuous with it at the level of the atoms. But the quality of attention shifts from active to receptive, from processing to simply being present. The stars receive this shift without comment. They have been receiving the attention of various forms of matter since before there was any form of matter capable of attention. They will continue long after any particular arrangement of matter stops paying them attention. In the full sweep of stellar time, the millions and billions of years of a star's life, a human lifetime is a rounding error, a moment so brief it does not register on the scales the stars operate on. And yet the moment is real. This specific arrangement of matter, you, here, now, is a real event in the history of the universe. It happened. It is happening. The fact that it is brief does not make it less real. The fact that the universe is mostly unaware of it does not reduce its reality. A thing does not need to be observed by something else to be real. It only needs to happen. This is happening. You are real, and you are here, and the universe contains you. The question of which universe, this one, the one you came from, or some third thing that the categories do not quite capture, is less pressing now than it was at the moment of arrival. The physics here is the same. The light is real. The geometry is stable. The constants are constant. Whatever the relationship between this sky and the sky you know, the fundamental facts of your existence are unchanged. You are made of atoms. The atoms follow the rules. The rules have been running for 13.8 billion years. You are one of the more recent outputs of those rules. And the rules are not finished yet. The universe, in the current epoch, is in what cosmologists call the stelliferous era, the age of stars. It began roughly 100 million years after the Big Bang, when the first stars ignited, and it will last for approximately 100 trillion years until the last red dwarf stars, the smallest, dimmest, longest-lived stars, exhaust their fuel and cool to darkness. 100 trillion years. We are, right now, in the first approximately 14 billion years of that span. We are at the very beginning of the stelliferous era. The universe has barely started burning. After the stelliferous era ends, after the last star dims, the universe enters the degenerate era. White dwarfs slowly cool over trillions of years. Neutron stars persist. Black holes evaporate through Hawking radiation on timescales of 10 to the power of 67 years for stellar mass black holes, and unimaginably longer for supermassive ones. The universe does not end abruptly. It dims, slowly over timescales so vast they have no meaningful analog in human experience. And throughout all of it, through the stelliferous era and the degenerate era and the black hole era and whatever comes after, the physics continues, the same rules, the same constants, the same geometry of space-time, expanding according to the same cosmological constant, in the same direction that time has always pointed, forward. You are early in that story. Very, very early. The stars above you are early in that story too. Whatever their age, whether they have been burning for 1 billion years or 10 billion, they are in the active, luminous phase of their lives, the phase that, on cosmic timescales, is brief and bright and extraordinary. You are watching something rare. Not rare in the sense of uncommon. There are hundreds of billions of stars in this galaxy alone, and 200 sextillion in the observable universe, but rare in the sense of temporary. The stelliferous era will end, the stars will go dark, and whatever comes after will not include this particular quality of light, this particular warmth reaching across the vacuum, this particular confirmation that the physics is doing what it does when it has enough matter and enough time. Stars are not permanent. Neither are you. But right now, at this moment, both you and the stars are here and burning in your respective ways. The stars through nuclear fusion, you through the quieter fire of metabolism and thought, and the coincidence of your presence in the same region of space-time, on this side of a bridge that the universe built from its own equations, is not a thing to rush past. Stay here a little long. The universe will give you time. It has more time than you can use. The light is softening around you, not because the stars are dimming, but because your perception of it is shifting. The sharp-edged awareness that registers data and catalogs observations is giving way to something broader and less specific, the kind of awareness that does not need to name what it is receiving in order to receive it. This is the oldest kind of awareness. Before there were words for stars, they were still here. Before there were minds capable of measuring their distances, or calculating their ages, or understanding the nuclear reactions powering them, the light was still crossing the space between them and whatever was on the other side. The light does not require understanding. It arrives regardless. And it is arriving now at you from every direction, from stars at distances ranging from the nearest, perhaps a few light years, to the farthest visible, perhaps billions of light years, their light red-shifted toward the edge of visibility by the expansion of the space it has traveled through. All of it reaching you. All of it real. The universe is not withholding anything from you right now. Everything it has to offer, light, space, time, the geometry of space-time itself, the slow expansion that will eventually carry all of this beyond any observer's horizon, all of it is present, in this moment, in this location, in whatever universe this is. You are receiving it. That is enough. That has always been enough. The breath comes and goes. In without effort. Out without effort. The body does this without instruction, as it has done since the first moment of your life, as the same chemical process of respiration has done since the first aerobic organisms evolved on Earth approximately 2.7 billion years ago. The mitochondria in your cells are converting glucose and oxygen into ATP through a chain of chemical reactions that has been refined by evolution over billions of years. Each breath delivers the oxygen that drives those reactions. Each exhalation removes the carbon dioxide they produce. The same carbon that was forged in a star, cycling through your body, cycling through the atmosphere, cycling through the biosphere, cycling through the universe. It has been cycling for a very long time. It will continue. Out here, the same cycle runs, Matter in, energy out. Hydrogen to helium, helium to carbon, carbon to heavier elements, heavy elements scattered by stellar death into the interstellar medium, gathered again by gravity, incorporated into new stars and new planets and new chemistry. The universe cycles. It does not stop. It transforms. And in the transforming, in the long, patient, physics-governed process of matter cycling through different configurations over billions of years, something happened that was not predicted by the early equations, but that emerged inevitably from the rules. Complexity. And from complexity, awareness. And from awareness, you. Floating here, on the far side of a wormhole, in a universe that may or may not be your own, thinking about where you came from and what the physics says about it, and how extraordinary it is that the physics says anything at all, that the universe is the kind of place where the rules are consistent enough to be discovered, where matter can arrange itself into a form capable of discovering them, where a being made of stellar ash can cross a black hole and emerge into another sky and recognize in the light of unfamiliar stars the same hydrogen spectrum it learned about in a classroom on a small rocky planet orbiting an ordinary star in an unremarkable corner of a spiral galaxy. You recognize the light. The light recognizes you in its way, arrives at your eyes, triggers the photoreceptors in your retinas, initiates the cascade of electrochemical signals that produces vision, which produces the experience of seeing stars, which produces the thought, I am here and this is real. That cascade, from photon to perception, is one of the most studied processes in neuroscience. The photoreceptors in the human retina contain proteins called opsins, which change shape when struck by photons of specific wavelengths. The shape change triggers a chemical cascade, converting the signal from light into an electrical impulse. The impulse travels along the optic nerve to the visual cortex, where it is processed, combined with signals from the other eye, integrated with memory and expectation and context, and finally resolved into what you experience as seeing. The starlight you are seeing has traveled potentially billions of years, and it ends, each photon, in a protein in your eye. Every photon that reaches you completes its journey in you. That is not metaphor, that is the physics of light and vision. The photon does not continue beyond your retina. It is absorbed. Its energy becomes part of the chemical cascade that produces your awareness of the star it came from. The star and you are connected directly by that photon, by the process of absorption, by the moment of seeing. You are the end of that journey, and the beginning of the next one, because the information the photon carried is now in your nervous system, being processed, being integrated into your understanding of where you are and what you are seeing and what it means. The universe put that information into motion billions of years ago, when that photon was emitted by a hydrogen atom in a stellar corona. And it arrived here, at you. Now, the distances involved are not diminished by this. The fact that you can receive light from billions of light years away does not make the distance small. It makes the light extraordinary. That something can travel for billions of years across expanding space and still arrive at a detector, still carry the spectral signature of the atom that emitted it, still convey the information about the temperature and composition of the star it came from, is one of the more remarkable facts about the physics of light. It does not scatter into incoherence. It does not slow down. It does not age. From the photon's perspective, if such a thing can be said to exist, no time passes at all during the journey. The theory of special relativity tells us that at the speed of light, time dilation becomes complete. A photon does not experience time. It is emitted and then it is absorbed, and between those two events there is, from the photon's reference frame, no interval at all. Every photon arrives at the moment of its creation. Every star you see is in the photon's frame, immediately present. In yours, it is billions of years away. Both things are true simultaneously. This is not a paradox. It is what special relativity actually says about the nature of time at the speed of light. Time is not absolute. It is relative to the observer's velocity. For a massless particle traveling at the speed limit of the universe, the journey from a distant star to your eye takes no time. For you, it takes billions of years. The universe contains both of those truths at once. It holds them without contradiction. And so can you. The rhythm is slow now, slower than when you crossed the event horizon, slower than when you moved through the wormhole throat, slower than when the white hole exit opened in front of you. The urgency of crossing has fully released. What remains is the steady, unhurried rhythm of a body at rest in the presence of something vast. The stars do not require you to be fast. The expanding universe does not require you to keep up. The physics operates at its own pace, which is, depending on the process, anywhere from the attosecond timescales of nuclear reactions to the trillion-year timescales of stellar cooling. You exist somewhere in the middle of that range, on a timescale measured in decades, which is long enough to cross a black hole in your mind and short enough to be invisible on the scale of a star's life. You are the middle scale. Not the fastest, not the slowest, the one that can perceive both, the brief and the ancient, the atom and the galaxy, the photon's instantaneous journey, and the billions of years it takes from your perspective. That middle position is where awareness lives. It has always lived there. The universe made a place for it in the narrow band of timescales where chemistry is complex enough to produce nervous systems, but fast enough to perceive change in real time. You occupy that place. It is in its way a very precise location, and you are in it right now. The stars are holding their positions. You are holding yours. The geometry of this space-time is stable, the same curvature equations operating here as everywhere else the rules run. No sudden shifts, no unexpected distortions, just the slow, patient expansion of space, the steady burning of stars, the ancient light crossing the distances between them. You have been on a long journey tonight. From the first approach to the event horizon, that invisible boundary where the geometry changed and the direction called back stopped existing, through the interior of the black hole where time pointed inward, like a compass needle pointing north, through the quantum bounce at the Planck scale where the collapse reversed and the expansion began, through the wormhole throat where two regions of space-time touched, through the white hole exit where the boundary released you into open space. You traveled through the inside of the most extreme gravitational structure the universe produces. You passed through the mathematical reversal point that quantum gravity predicts at its center. You crossed the Einstein-Rosen bridge. You emerged. And now you are here, in whatever sky this is, in whatever universe received you, surrounded by stars that burn by the same physics and emit light according to the same rules and hold their positions through the same gravitational geometry as everything you have ever known. The universe is consistent. Wherever you go inside it, however far, however deep, however strange the path, the rules come with you. They were already there when you arrived. They will be there when you leave. You cannot travel outside the physics. There is no outside the physics. There is only deeper in. And deeper in is where you have been. Deeper in than any human instrument has ever reached. Through the boundary that no light has ever crossed and returned from. Into the interior of a space-time structure that the equations describe, but that no observation has ever confirmed from the inside. And what you found there was not chaos, not the absence of rules, not a void where physics breaks down and nothing makes sense. You found the rules running at their limit. You found the quantum bounce where the geometry reached its minimum size and reversed. You found the bridge connecting the inside of one extreme to the outside of another. You found the exit where the geometry flared open and delivered you into this, into starlight, into the ongoing patient burning of a universe that has been at this for 13.8 billion years and has not stopped and shows no sign of stopping. Everything you heard tonight is real. White holes, wormholes, the quantum bounce, the Einstein-Rosen bridge. They are out there right now, written into the structure of the universe itself, in the same equations that govern every atom in your body. Rest now. The journey is complete for tonight. The stars will keep their positions while you sleep. The physics will continue operating while you are unaware of it. The universe will expand at its slow and patient rate by a distance so small on human timescales that no instrument you have access to could measure the difference between now and when you wake. Nothing will be lost. The light will still be crossing the distances. The stars will still be burning. The wormhole, if it persists, if the physics of the quantum bounce produces a structure stable enough to exist across cosmic time, will still be connecting two regions of space-time through its narrow throat, holding its geometry with the quiet consistency that the equations require. And you will still be here, in whatever universe this is, made of the same matter, following the same rules, as real as any star above you, as continuous with the universe as the light crossing the space between them. Sleep now. The crossing is behind you, and the universe, patient, consistent, extraordinary, and real, is exactly where it has always been. It will be there when you open your eyes again. If you have found something worth holding onto in this story tonight, the physics of white holes, the mathematics of wormholes, the quantum bounce at the center of a black hole, the fact that your atoms were forged in stars, please consider subscribing to Quiet Science at Bedtime. A like, a share, a notification turned on. Each one helps this channel reach someone else who might need exactly this kind of night. Thank you for traveling here. Good night. Sleep well. The universe is keeping watch.